Welcome to episode 3 of Wi-Fi scanner project. In this project, we are going to display the scanner result on the TFT display. And we have seen in episode 1 how we were able to display the scanner result on the serial monitor. And in episode 2, we have taken a step forward and tried to set up a display framework using 2.8-inch TFT ST7789 TFT display. In this episode, we will combine both the project and try to enhance a step forward and use the TFT screen to display the Wi-Fi results that we were able to achieve in episode 1. By the end of this episode, we'll have a good looking Wi-Fi scanner entirely used on the ESP32 displayed over TFT screen. There is only one change from the wiring perspective that we have done from the episode 2. That is, instead of GPIO 2, earlier I was using GPIO 2 for the DC pin, and for that we have changed it to GPIO 27. And the reason why we changed that GPIO 2 to GPIO 27 will let you know in detail when we look into the code and the issues that was faced. So before further delay, let's jump into the code and the changes that we have done and how we have enhanced that. We'll go in detail step by step so that you are able to build this project easily. To reuse the scanning code from the episode 1 as mentioned earlier and reuse the TFT framework from the episode 2. So we'll combine both the project and display the Wi-Fi scan result on the screen. Few additional things that we'll do is, instead of in like episode 1 you have seen a single INO file, but in this episode we are going to separate out the project into multiple source file. Like we'll separate out the config, the theme, the display part, actual display part, and the scanning code. So all this will separate out and build a reusable framework so that we can enhance further and easily whenever we need it. So if you want to enhance the display, we just need to change the display code. If there is any config that we need to update, that we can use only the config.h file. So depending on that, we'll just separate out so that it is easy. And then at the end, we'll see a troubleshooting and fixing of a real hardware issues. So we'll see what all different issues that can come up and how we can fix it. And we'll explain my experience on what issues that I have faced while completing this project, so that it is easy for you to overcome those issues easily. So we have divided this single file into this 5 files basically. The scanner will remain, the scanner part is still in the INO file, and the config, like what should be the SPI frequency or any other configurable items, I moved into the config.h. Then we have a theme.h where we have just defined the color coding. So the theme that I am using, and I have defined that color code. So if you want to change the say text color, or if you want to change the background color, so we just need to update this theme.h. Then the display manager will be the layout part. So the way in this I am displaying in a tabular format. So the way that table will look, or whether we want to have additional row or additional column on that. So all those changes can be done in this display manager.h and display manager.cpp. So we have a separate class and we have used this. So the coding structure is based on this C++, and it uses the embedded programming. So it will help you enhance this later on if you want to change. So it is easy to make changes to the code, and also it helps in debugging. If there is any issues, it is easy to debug, and because we can separate out the problem area easily and only focus on those files. The next change that the next thing that we need to see is the pin connections. So if you are following my episode 2 video, the pin connection that I had done, if you can show you. So in this the previous episode, what I have done is, these are straightforward VCC and ground. So we are using 5-volt for the display, TFT display, from the 5-volt of ESP32. Ground, CS is GPIO 5, reset is GPIO 4. The one change that I did is, the earlier for the DC pin I was using GPIO 2, but in this project I changed this to GPIO 27, and the change was because of some issues that I was encountering while using GPIO 2. So as I explain further, so we'll see what issue was there. In the last stage I will explain you the detail on the issues that was there and why I changed this to GPIO 02 to GPIO 027. And the rest of the pin connections remain same. There is no change from the previous. In fact, all the other pin connections are same. So if you have already connected and completed the episode 2, you can use the same wiring without changing. Just remove the GPIO 2 pin and connect it to GPIO 27. That will be the only change that you need to do, and rest is from the wiring perspective, there is no other change. The other change that we'll be doing is this in the file, and we'll see shortly after this. So the way we have structured is, the way we have created that, so you need to put all these files into one folder, and when you open that INO file, the Arduino will create a folder as it does for all the other files, and then you just copy paste all the other supporting files in the same folder, and what will happen is that it will open up in a new tab as in this way. So you will have different tabs for each files, and it will open. So you need to just, when you open your file, you just need to open the INO file and the Arduino IDE. The rest file will come up in the as a tab. But you need to keep in mind that you need to place all the file in the same folder. So I can show you just that one once opening. So you just go and open the file. So I am selecting this, only the INO file will show when you try to open the file. If you open this, let's look into our previous code. So if you go to the GitHub repository, or if you are already using this in following my project, so you might have it in a local. So if you see here, the setup part or initialization, everything was done in the same file in the setup method, and then in the loop we are scanning the network and displaying the results, everything in the same. So if this part, the scanning the network, and then the result we are displaying using the print network info, so printing the header and then displaying. So this is again, print header is again printing the details header info on the serial monitor. Similarly, the print network info, we are displaying it in the serial monitor. So we loop through each SSID and then display it on the serial monitor. Similarly, if you look into the episode 2 code, the display framework where we have used that. So here also, if you see all the display related stuff, whether that is initializing the display, or you're changing the invert display to false, or if you're rotating the display, everything is in the same file, and in the setup method, like drawing part, colors, like pixels, where to display what. So all those header information, so everything is in the same setup method. This is what we have changed in the current implementation, where we have separated out into different files. And one more thing you need to see, in the user setup.h, as I mentioned earlier, since we have changed the DC pin, so earlier in the setup we had updated this file. So you need to go back and update this TFT underscore DC to 27, because we are now using pin 27. So we have created the theme.h, one file will be theme.h, where we have all the specific color settings, like what should be the background. Like I'm using TFT underscore black, so it's a black background. The header color, so navy blue, and header text white, column background dark gray, column text white, and so on. So if you need to change something, like if I want a strong signal instead of or say color text instead of white, we want to display it in cyan color or a blue color, we can use change just over here and it will take effect. We don't need to go into other files. Similarly, display the config.h. So here we have just wherever possible we have removed the hard codings and just placed as a config item. Like if you want to change the display resolution, if your display is not 320 by 240, then you can change over here. Rotation, what rotation we want to keep, whether 3, 0, 1. So if you remember in the episode 2, we have seen the rotation. So we use 3 and the display invert as false. So just remove that part and the hard coding part into this config.h file. Similarly, the font size, layout, and other plus the Wi-Fi scan interval. So it is 10 seconds right now, and how many network is visible, right? So that in this we have restricted to 9. We are not adding a pagination or scrolling effect. So this config item is also over here. So all this we are using it in our actual codes. And then the display part. So for that we have created a display manager class and defined in this .h file, we have defined the declared the methods, and using it for the definition of the methods is in this display manager or CPP file. So if we go through details, the initialization, display initialization we have used over here. So this is, and just filling the background with the background color. Then in the draw header, this will draw just the header part, like what should be the header column and those text it will draw. The display column header will be actually displaying the column header along with the different colors. Then the footer is similarly this, it will display the footer part. Next, this is clearing the network area. So we are, when we call the refresh or new scan result, this part will be clearing out all the data and clearing the screen and then update with the new one. The draw network is basically the the most important one, where we are actually displaying the scan result on the screen using this method. So we have calculated the row row by row pixels, and then using that and displaying the details on that screen. So here we are this method we are calling from the our actual scan in the Wi-Fi scanner.ino file. We are calling this method. And one more important one is the actual dashboard display, the screen header and width. And if we want to refresh, like this is hard refresh that we have declared. So this was declared because there was some issue and we wanted to refresh our screen. Sometimes the default refresh doesn't work, so we need to use this one. So this all our methods are defined. So all the files I will be uploading in the GitHub. So you can, if you want ready access, you can directly download it from there and make changes according to your requirement. So this is the display manager. The Wi-Fi scanner is this where we are having the heart of the project, that is the scanning, and this has most of the code from the episode 1. So first we'll see the header. So this is same, no change in this one. And here if you see, the two things that we are calling is display begin. So this is the same method that we have declared in the display manager. So where we are initializing and setting the rotation and the display and inverting the display. So that part is over here. And then the draw dashboard. So it will first draw in the setup the empty dashboard, that is with the column header, footer and the column details. So all this it will draw in the first screen, that will be the empty screen. I will show the actual output shortly. And then this loop part where the actual scanning works. So here we have scan networks, one method. This is where it will call, so and then print the scan finish. This is a debugging. For debugging I've added that two statements. And the delay, so we have given a 10 seconds delay, so after every 10 seconds it will scan the network. So all the other things are happening in this scan network. So we'll go, this is the not the right scan network method. So the scan network method is over here. So I added, so if in your code, if you are facing some issue, you can display some static scan network data and just check whether you are actually getting the data correctly on the screen. So you will be able to separate out if there is any issue with the scan network method, where we are actually scanning the networks and displaying the Wi-Fi results on the screen. So ideally you should not have any issue, but in case you have issue, you can use that. So you can just comment out the actual scan network and use this, which the way I had done in my project. So the next thing is the scan network, which is the heart of our project, and this will display the actual Wi-Fi details. That is, it will scan and then this call the display method to display. So first we'll call the scan delete, because it will, if there is anything from the previous data scan result data, we'll clearing out from the Wi-Fi object. Then this call will just call the, it will scan the Wi-Fi network and store the number of networks that it is scanned into this variable. After that we are clear network area. So this is same method we have displayed in the display manager.cpp. So it will clear that. So if you see, it will I have declared, right, it will clear the network area. So it will clean that call the dashboard. And so if you are running this, if the scan is the second scan, so there may be something displayed when you have scanned the first time, so it will clear off. This is just a debug statement I have added. So this is one way to debug your code. If you are facing issues, you can place the print statements in between and see till where your control has come. So now that we have successfully complete, we can remove this after that. And we are displaying just, this is also the debug statement, displaying the total number of network that I have found while scanning. So after clearing network, we are displaying the footer with the number of networks. So we got the value, let's say maybe 10, 12, 13, whatever it is, we will display it in the footer. So next is, this rest of the code is same, where we are looping through the number of networks. Only one additional things I have added here. Instead of hard coding that we want to display 8 or 9 results, I have used this config item variable and using the result from there and checking the like restricting the display with only 9 Wi-Fi SSIDs. This code is same. So if we don't get any hidden, if there are hidden network, so it will be empty. In that case, we are displaying this hidden in the SSID name. This is the, so here we have changed. So if you have observed my earlier scan code, we can just see, quickly go back and see how we have used that. So here, if you see the display part, we are using this print network info. And if you go back to the network info method, here if you see, I am using the printf statement. So this is a little different than what we are right now. So this part only we have changed it. So instead of displaying it on the serial monitor, now we are calling that network the display, this display manager .net. So the display network .network, and this is the only change, like basically enhancing the code change that we have done from our previous is, instead of displaying it on the serial monitor the way we did it in the episode 1 and we moved it to the from serial monitor to the actual screen. The rest all are almost similar, so this method and the few other methods are same. So this is draw network. It will call, it takes this parameter, that is the serial the count, whether it's number first record, second record, then the SSID. This SSID will capture the SSID name, so whatever we have in this string, and then Wi-Fi.RSSI, it will the relative strength, then the channel number, and this is same code, the encryption type. So what type of encryption we have, so this is same thing, this we have defined in episode 1 also. So based on whether it's open network or WEP, WPA, so we are based on the encryption type, we are replacing it with a text equivalent text value, and we are calling this method. So this display draw network, if you can go back and see, it takes this parameter. The row is the row number, that the serial number, the count from the in the list, then the string, the SSID string, RSI number, channel number, and the security that it is using, and all this we are displaying at the bottom over here. So we are displaying the SSID, we are displaying this RSI in the second column, then the channel number and the security. So all this, and we have separated using pixel. So this calculation, if you are using some other TFT display, then you might need to change this calculation. And one more thing that you need to notice, that this, if you notice this part, so this is especially displaying the different color text for the strength. Like if it is a strong signal, that is the RSSI is greater than -50, so if we get 30, so greater than -50, then we are displaying at is a strong color, and strong we are using green. If you see the tooltip, so it is green. Here we have mentioned green. So this again, based on my theme selection, I have used green. Based on your you may display using some other color. And same with, if it is a medium strength, it is a different color. If it is a weak, we are displaying it as red. One more change, if you see this part, so because the string length can be SSID text can be long, so we are restricting that with 10 character, and you can use 15, 10, whatever it is, and I am making it to 13, so giving a 2 pixel gap, 2 text gap also, so that there is no issue in the layout. So you can display max, since we have checking up to 15 length, so we can display max 15 characters also. So this is where we are restricting, and it will not show the complete name if the SSID name is too big. So this is the actual heart, you can say, along with the scan result, the scan network method, and the display managers, this particular draw network. So this will actually show the result on the screen, and based on the color, what colors we want to use, we are using it. Now that we have completed the walkthrough of the code, let's move into the actual hardware. So we'll compile this and upload. By the time it compiles, I will just pause the video for some time and then come back again. Now that the code compilation and upload is done, so we can go through and see the actual output. There is nothing in the serial monitor, just few debug statements, but I'll will switch the camera and show you the actual output, how it looks like, and then we'll come back again into the screen. You can see the output on the scanner, and connect, this is the ESP32. So if you just observe the dashboard, so the Wi-Fi scanner, and then the blog name, then we have first column the SSID, second RSSI, and the color, if we see the RSSI color, if the strength is greater than -70, it is showing in the different color, and if it is -70, it's different. If it is weak, it will show red. So that so far there is none of the network showing as weak. And then third column is the channel number, and then the security. So whether it's a WPA2 or something else that displays, and it refreshes every 10 seconds. At the bottom, if you see the total network that it has scanned successfully, that it is showing 23, and on the right side there is one scanning logo that is displaying, because it is continuously scanning every 10 seconds. So few things that we were able to achieve in this video are, like, first we were able to functionally run the scanner, Wi-Fi scanner, and display it on detect the network SSIDs, nearby network SSIDs, and display it on the TFT dashboard with a decent UI. So next target will be our to enhance this. Before winding up, so we'll discuss on the issues that we faced earlier, and I think in the initial part of the video I had mentioned about the issue of GPIO pin 2. So basically what was happening is that in the GPIO pin 2 we were getting a blank screen. After the initial blank dashboard display, it was not showing any data on the screen. So that's why you might have noticed that I have tried to debug that issue by first, instead of passing the scan network, I just passed a dummy scan network with the static data and see whether it was displaying. So the result was positive and it was displaying. So which means the issue was in this scan network. But the scan network, as we demonstrated earlier, there is no change in the core logic from the episode 1, so which was working. So in isolation, Wi-Fi scanning was working. In isolation, the display is working. So the issue was when we merged both of them. So after few debug and few research, we found out that the issue was the GPIO pin 2, which was interfering with the Wi-Fi radio signal, and after the refresh, it was disturbing the SPI SPI bus. So to be on the safer side, I just tapped the pin GPIO pin 2 with GPIO pin 27. So this was one of the issue, and in my project I encountered only this issue, but there are chances that you may see some other issues, like especially the display, whether the display is correct or not, layout issues. If you are using the same display which I am using, then probably this the sample files that I have, it should work without any issue. But if you have some other display configuration, so you may need to change the pixel locations and calculation, which may distort the UI. So you need to do some hit and trial. Otherwise this should work on the standard display. If your display is using 320 by 240 layout, it should work properly. Also the few things that we discussed in the previous video, like the scan like not the scan interval, the display rotation and the display invert. This may also may be different for your project, so you can, based on the first output when you compile and upload, you need to just maybe change this values and to match your display configuration. Along with that user setup file, there I have changed the SPI data frequency. So other thing that while preparing, like working on this project, just make sure if you are debugging, try to follow the print statement as I mentioned earlier. In between you can add print statement, and so that you can get to know till where the code has been executed and used as an output, and just try to debug accordingly. So finally, what we concluded with the issue that I had faced is that the problem may not be always the software. It may look like it's a software issue, but the issue was with the hardware, where the particular jumper wise was not it was disturbing with the actual data flow. Do let me know if you have any issue and you are able to build it. If you have any issue or any comments, do update in the comment section. I will try to respond as soon as possible. And just to update on the follow-up to this video, we'll try in the next episode, we'll try to enhance this display a little and take it a little step forward, and we'll display the sorting results, the network results in the sorted order. So we'll try to sort on the signal strength, but maybe we can add that as a config item, and based on the requirement you can sort on other parameters also. And display, try to implement a scrolling or a pagination so that we have multiple, we are able to display all the networks, and will improve the refresh, so make it more smoother refresh and a little tweaking in the UI and optimize it. From the hardware stuff, in the next episode we may not be making major changes, or maybe will not make any changes in the hardware. And in the episode 4 we'll try to focus on just taking this code and making it a more polished and a very stable code, so that with all different other enhancements from the UI perspective. Thank you again, and see you in the next episode.